Hi, welcome back to the class. We are in the chapter Wrangling Data, and in this section we're going to be focusing specifically on how to transform and analyze data using the package dplyr. So why do we use dplyr? It's a package created by Hadley Wickham. It works best with data frames, which is what journalists are used to. It's great for data exploration and transformation. It's intuitive to write, easy to read, especially when using the chaining syntax of pipes, which we will be getting into later. And it just operates fast on data frames. So we are going to be working with some pretty big data, the murders over the decades across the country. It's case level data that was acquired by the Murder Accountability Project from the Justice Department. And it's pretty much the same data that we used in the previous chapter for the importing data from SPSS. If you recall, that was about 100 lines of code. I've saved it as a script here. I'm going to open up the dplyr folder, and here it is, import_murders. This is pretty much the same code as before, but saved as a script. And because it's saved as a script, I can just run it, and it'll run all that code every time we need to pull in data like this. So if you open up the pipes-dplyr.rmd file, you can press this little green play button to load it right away, or you can set your working directory to the files pane location, because I'm in the dplyr one, and it sets the WD here to there, and I can type in, because I'm going to pretty much write this all from scratch, source import murders.r. Now this is going to take a few minutes to run, and while that is loading all this data, I'm going to talk about the 5 basic verbs that we're going to go over in this section, and that's filter, select, arrange, mutate, and summarize, which is often used in conjunction with group by. Okay, and the data is loaded. So we have about 750,000 rows of data. If you take a look at it, it's got quite a lot of variables. There's the data dictionary is linked into into the code through. So when you get a new data set, what I like to do is I try to examine it real quick. I want to see how large it is. I can see in here that it's 750,000 rows long. Another way to do it is just through the command nrow murders. Murders is the data frame, name of the data frame, so I just run that, and that lines up with the number. So let's see, we have municipalities here, MSA_label. How many of those are there? So we can do that by typing in, I'm going to just create a new variable called how many. I'll type it up here for you. How many? Arrow unique is the function. Murders $MSA label. I press Command Enter to run that line, or I could press this little green arrow run, and I have about 411 maybe. And so then I can type in length just to double check how many. Okay, so there's actually 409 municipalities. So let's not overwhelm ourselves with all this data we're getting. What else do I like to do after I take a look at like all the aspects of it? Another thing I like to do is take a look at all the columns or variables. So a way to do that is use the function glimpse. And when you run that in the console, it'll give you a list of all the variables. It'll give you the class of all the variables, factors, digits, factors, and it'll give you maybe the first few instances of each one. So this is important to know, because now I see that numbers aren't really recognized as numbers sometimes. Strings are recognized as factors, which can be a problem when wrestling with this data later on. So it's important to kind of get a sense of what variables there are and how many types of them there are. The more variables you have in a data set that are categorical, the deeper you can dive in analyzing it. So for example, if you had a data set with a list of salaries, like only one variable, you could figure out the median salary, or you could calculate the difference between the highest and lowest salaries. If you had a data set with two variables, like salaries plus gender of worker, you could additionally you could figure out the median salary for men and women, and then calculate the difference in those medians. Now, if you had three variables, salaries, gender, and state where they live, you could find out median salary per state, figure out median salary for men and women per state, determine which state had the biggest disparity, and see in which state men or women get paid more. So this is what we're going to do with this data set. Well, let's narrow down the scope by using filter. So filter works by extracting rows that meet a criteria you set. So the function is filter, and the arguments that you pass to it, the first argument you pass is the name of the data frame, and that's murders. And after this, you can put in one more like logical tests to filter it by. So you can do, let's say I'm going to create a new data frame called df1, arrow filter murders, and I want to filter it by relationship label. Look for husbands, and then victim age is older than 60, and I'm separating with commas, and that means and year is 2016. I'm going to run that. So you get an error, and that's one of the things I was going to warn you about. When you're doing a filter, logical tests require two equal signs. Otherwise, it's assigning relationship label to husband, or husband to relationship label. So there. Now it works correctly. And I have narrowed that down to 25. Out of 702,000, there's about 25 cases that match that particular criteria that we set. So I'm going to show you another way to do this same kind of filtering. Instead of the commas, you type in ampersand. So equals husband, and instead of comma, vic age greater than 60, comma, year, not comma, and ampersand, year equals 2016. And it overwrote it. So let me run both of these now. 25, 25, 47, 47. So lines up. Another way to filter that is very useful is when you can filter by groups. So let's say you want to filter murders by both husband and boyfriend. Any cases with those. So label. So instead of doing relationship, you could do equals husband or relationship label equals double equals boyfriend, but that takes up a lot of space. So what I'm going to do is use this other command, which is % in %, and then pass it a combination, an array pretty much. So first is husband, comma, boyfriend. So that does the same thing as the other pipe or command that I showed you. So that plus or pipe circumstance label equals lover's triangle, which was one of them in here. So let's run that. I've got 32,000 now. That matches either the relationship to the victim was a husband or boyfriend, or it was lover's triangle. So let's see. Husband, boyfriend, and acquaintance is in here because lover's triangle was in here. See? Relationship not determined, but it was a lover's triangle. And that's the filter that we set up. So there's a list of logical operators I've included in the site. There's less than, greater than, less than or equal to, greater than or equal to, doesn't equal to. Doesn't equal to is, looks like exclamation point equal sign. So that's the opposite of equals. Okay, that's good to know. You've got the pipe for or, ampersand for and. A couple of other ones is true. This is if something is true or not. And then is.na. We'll check if a value is not there or not. Sometimes you'll have data with that, and it's important to filter it out that way. The opposite of that is it is not is an A, and that means is it not an A, and that is false because it is. Anyway, so I already showed you one wrong way to do it, and that's if you do a one equal sign in here. Error. The right way, of course, is two equal signs. Sometimes another wrong way to do it is if you forget to put quotes in. Because without the quotes, it's assuming that it's an object that you're passing to it. Okay, so if I did how many, well, that wouldn't work because it's factors. So you also need to pass it in string. So let's say type is husband. If I pass type into here, because it's in our system already as husband, it will filter correctly. Another thing to look out for is instead of stringing together the ors, relationship label equals husband, relationship label equals boyfriend, or relationship label blah blah blah. You do this in percent. It'll save you so much time. It's wonderful. Okay, next verb I'm going to show you is select, and that's extracting variables or columns with that select function. All you have to do is list the column names that you want to get rid of. I'm sorry, that you want to pull from. So you know how filter pulled out and extracted individual rows. Select does that for columns. So all you have to do is, let's say, create a new df1 arrow select, and the first argument, just like before, is the name of the data frame, and we're going to use df1, and I want to pull in, say, state, agency, solved, label, and then year, and I just type it out. And this is why it's important for your column names to be single. I mean, pretty much no spaces or characters, because if you put in a space here, it'll give you an error. So you have to put in underscore. There are ways to handle spaces when you're dealing with column names, and I will show you how to do that eventually. But for now, let's just move on. And so I have df1 narrow, and you see it went from 47 variables to 4. Check that out. You got state, agency, solve, label, year. Pretty cool. So you can add a colon between two variables. Actually, I'll keep that. Just copy and paste the code that I want to redo. Change it up. And now this time I'm going to put a colon between solve, label, and year instead of a comma. And what do I get? I have 5 variables now because solve value was in between. Let's see if I can pull it up again. Solve value was in between solve label and year. I can expand that more. What if I wanted all the way to incident? I want all the columns between solve label and incident. Then I just type it in. Incident. Run that, and I've got 8 variables now. Pretty cool, right? You can also use a subtract symbol to remove columns, because it would be a pain in the butt to type out 46 variables if you just wanted to get rid of one variable. So let me show you what that looks like. Select df2 narrow minus incident. Okay, so you see how df2 narrow is one variable larger than df3 narrow because we got rid of one of the columns. So there are so many other functions you can use with select to help make your life easier. For example, I want to extract variables that contain the name labels, let's say, because that seems to be every other one: label, 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 etc. So let's try that. I'm going to call this labels only columns and use the select variable. And I'll try murders, comma, contains this time, and then pass it the string, underscore label. Run that. How's that look? Look at that. Labels only. Alright, I'll show you one more in this video, and that's arrange. And that's pretty much sorting. Okay, the first argument you give to it is the name of the data frame, and then what you want to sort by. So let's start over again. Age df1. I want to arrange it by the murders, and I'm gonna do it by victim age. So when I check that out, I can scroll over to the age column, and it's all zeros because if you keep going, there's a lot of those. You can pass it more than one variable to sort by. That would act as a tiebreaker. Type out it correctly. Murders is the data frame. Vic age is what I want to sort first by, primarily, and then tiebreaker offender age. Let's take a look at that. And just comparing that with this one, the first one was Mesa, Arizona, and now the first one is East Point, Georgia. Alright, and that's because the ages are now sorted differently. So now the youngest age, wow, 2. Okay. You can, instead of going from into ascending order, lowest to highest, you can reverse that by just wrapping it in descending parenthesis function, pretty much. So age df3, arrange murders, vic age, comma, descending this time, offender age. Let's run that. Okay, and now the first one is Connecticut Waterbury. So we have someone. Oh, offender age is 9999. We need to be careful about that. That's what happens when you've got. Well, let's take a look at the range. We use the function table, pass murders off age. Wow, look at that. So if we tried to figure out the average age of these folks, we'd get something weird. There'd be 250,000 cases with really old, ancient people. No, see, what happened is the police, when they don't know the age of a victim, they'll put in 999 in this data set. So we would need to filter that out. So let's do age df2 again. And this time first filter it. Oh, start off. Age doesn't equal 999. And then I can pass that on to here. Age df2 is the new data frame. And I've now reduced it to 500,000. And so it is back to Georgia East Point. 0, the oldest person is victim age, offender age. There it is, DF3. I was looking at the wrong data frame. And it's Volusia County, Florida. 0, 84-year-old, 0-year-old. Okay, so this is the, we've gone over a few verbs already. We've gone over filter, select, and arrange. And next we'll go over mutate and summarize and group by and a few other things. So I'll see you in the next video.